Okay, so just to review, the domain is the independent, and it's the x values, whereas the range is dependent, and it's the y values. So here we have discrete data. This is all discrete, okay? So we're going to just list the values. They're just specific points. So what's our domain for the first one? 0, 1, 2, 3, 4. All we have to do is list our x values. Super easy. And then what's the range? 1, 2, 3, 4, 5. So for the range, we're going to list the y values. Okay. Sometimes we'll be an XY chart, and sometimes the chart's sideways. Please list the domain and range for number 2. Go. Okay, any questions about domain and range for number 2? Now number 3, okay, it's in a graph, who cares? List your domain. Domain is your x values. So simply start on the left and go to the right. Don't double up. Okay, then list your range values, which are your y values. Start on the bottom and work your way up. So for your range values, you start at -5, then you're at -2, then you're at +1, +3, +6. Okay? Now, is it a function? Well, you have to use your vertical line test. Well, you don't have to, but you can. And you'll see this red line, it touches these 2 dots at the same time. That's your big no-no. It also happens over here. Come on, thing. I'm sure why it's doing that. Usually it's pretty good. There we go. Okay, forget it. So here it fails and there it fails. So it's not a function. Because there's 2 reasons. You just have to list one. It fails the vertical line test. Because it's a graph, you can say that. Or you can also say there's 2 outputs for the inputs -4 and +2. Okay, so either or. All right, good. Now determine f at -7. So we're saying x equals -7. What's your y value? Well, -7 for the x value. That's right here. So your y value at f at -7 equals +3. Okay. Any questions? Okay. So that is for discrete data. Now we're going to work with continuous data and it gets a little bit more tricky. Okay. So for continuous data, we're going to have these types of things. This is less than. This one is more than. This is going to be an open dot. Okay? And that's because it excludes the point. Then the opposite will be these ones, where you have the equal to part. So you have a closed dot, which includes the point. Now what we can do is we can combine these together. So if you have x and you have those two symbols, then you can have a low value and a high value. And this is a way of saying that x is in between. Okay. Now you have all these different combinations, because you could also say x is greater than a number, but it's also, or equal to, or x is less than a number. So the in-between idea kind of combines two inequalities together. It's a shortcut. All right, and you'd start at the middle and read to the left, and start in the middle and read to the right. So it's just think of it as in between. I think that works well. So a circle, when you graph a circle, this is really common. X is in between certain values. So what's the low value? Well, that's right here. And the high value is right there. And x is in between all those points. So it's like you're kind of smushing the graph to your axes and squashing it. And so you have a closed circle on the left and a closed circle on the right. So we actually have to have the equal to parts. So check your inequality signs. You must have the equal to parts on the bottom. And your low value is 1, and your high value is 7. So we're saying x is greater than or equal to 1, and x is less than or equal to 7. Well, that's a lot of stuff we just did there. Any questions? Think you guys can do this? So for the range, now we're talking about y. So it's going to be very similar because it's a circle. But instead of smushing it to the x-axis, what we're going to do is smush it to the y-axis. So we touch this point here and all the points in between until we get to the bottom point. So what are all the possible values for y from the top all the way down? The low value is -3, and the high value is +3. Is that a function? No, because it fails the vertical line test. Okay. Okay, you guys okay with the range for y? Any questions about that? Okay, let's practice it a little bit. What about the next one? Notice how the graph is starting here, but slowly going out. And it's also slowly going to the left and slowly going to the right. It's getting wider and wider and wider as it goes. Is anything going to stop it?
No.
No. So what we do for the domain is we just write down all real values or all real numbers. Okay? It's just a way of saying there's nothing containing it. What about the y though? Kind of looks like you start here and go all the way down. So this point on the y-axis and down. That's a 5. A y. What symbol should I use? Are all those values greater than 5? No, all those values are less than 5. But does it touch 5? Does it touch the line? Yes, it does. It doesn't have to touch it here. It's touching the line right here. And so that way we have to have the equal to part. So make sure you have this equal to part that I'm highlighting right here. That's really important that you have that. Okay. So it does equal to 5. So y is less than or equal to 5. Okay. Is it a function? Yes. And that's because there's one output for each input. Okay. Good. Any questions? You guys try the next one. So the domain is starting here, going to the right. What could it be? And notice how it's an open circle, so the point's excluded. Is x less than -3 or greater than -3? Greater than. So the sign should be eating the x. X is greater than -3. Okay. What about the y value? It's at this point and going up. So the point's -3 just by chance. What symbol? Greater than. Okay. And we cannot have the equal to part because it's an open circle. It's excluding those points. So we get up really close to it, but not touching it. Function or not? Yes. Okay. One output for each input. Okay. Turn it over. So now our interval notation. So we have square brackets. That includes the point. And then we have rounded brackets. That excludes the point. Okay, so this would be square and round. Now, infinity and negative infinity, these two we can never actually reach them, so they're always got to be round brackets. Okay, it's something that's a little bit weird for us. So this is something we got to memorize here. Make up some flashcards. You have to have it memorized. Okay. Let's keep going. So, for our domain, we're in between these points. Right? If we scrunch that line onto the x-axis, we're between those points. So what's our low point? -3, comma, and what's our high point? +2. Okay, square around the brackets now. What should we do for the -3? It's an open circle, which means we're excluding it. So for -3, we should have a rounded brackets. What about for the 2? Are we touching the 2 or are we excluding it? Good. So touching it means it's got to be a square bracket. What? Okay. Yeah, it does look weird. And that's interval notation. Okay? Low, comma, high. Low, comma, high. Range. Go for it. Okay? Now this is something that's cool. I love this stuff. This fills in the open circle. So it overlaps, it fills in the open circle. So the low value is -4, and that is actually a square bracket because it's filled in by the closed dot. What's the top line though? We're touching this here, 5. So should we use a square or round? Square. That's pretty cool stuff. Right? Is it a function? Yes, it is. Okay, one output for each input. It passes the vertical line test. Now look at the next one. This has a really cool domain and even cooler range. Remember how I said this gets filled in? So it's filled in, filled in, filled in. So when we smush this to the x-axis, this is a closed dot. This one remains open, but because of the dots, you get one continuous line. That's super cool. Okay? It smushes to a continuous line because the open dots get filled in. Okay, write the domain. And try and rate the range. The range is going to be really tough. Something you haven't seen yet. Well, give it a shot. So this should be bracket, square bracket, -5, comma, 5, rounded bracket. Hands up if you got that. Awesome. What about the range? Anyone get that yet? Jazz, what do you think it is? Okay, good ideas. Good ideas. Anyone else? Just guessing here, folks. You guys have never seen it before, so don't think you have to know it. Well, what happens if you smushed it to the y-axis? If you smushed it together, this top line would touch here. This next second line would touch there. The middle line touches at 0. This one touches at -2, and this one would touch right there. That's different, isn't it? So it's just continuous data. So we actually just have to list these. -4, -2, 0, 2, and 4. Okay, so we're breaking rules here, and that's because it's a very special graph. Okay, so it's like it's discrete data for your range. Is it a function? Yes, it is. Right here, it's only, this is included, but this point is actually excluded. So that means it touches only once at that point, at the top line. Weird, eh? It passes the vertical line test because of the open circles. Okay, and you've never seen that before either. All right, how you guys doing? Thumbs up, down the middle, what'd you say? Okay. Next one. What's the domain? Start here and go all the way there. Forever and ever. So what's the low value? -5. What's the high value? Goes forever, so it's infinity. Okay. Square brackets for -5, but do we ever reach infinity? Nope, so it's got to be rounded. So that's something new as well. Try and do the range now. Go. List your low and then your high. So your low value would be 0. Your high value would be infinity again. And you're looking at square and rounded. And yes, it's a function because it passes the vertical line test. Hands up if you got that one. Good. Okay, next one. So this here is a special it's just an equation of a line. This is in general form. Okay. So it's general form. It's a linear equation. For this one, it's always going to be all real values. And all real values. And this is always the case unless the slope is 0 or undefined. So it's something you're going to have to memorize. It's always the case. Always. Unless the slope is 0 or undefined. So unless it's like an x equal equation or a y equals equation. Because you can always turn this into y equals mx plus b. Okay. Now, you could do -infinity, positive infinity. You could do that as well for both of them. But just write down all real values and I'm happy, okay? So you don't have to do negative and positive infinity. Is it a function? Yes, it'll always be a function unless it's straight up or down. So, sorry, unless it's straight up. Okay. Let's look at the next one. X equals negative 11. Graph that. Make a quick little graph right here and just show me approximately where is that. So move the 11 to the other side, please. So add 11. X equals positive 11. What does that look like? Well, here's x equals 11. So what's the domain for that? 11. Okay, x equals 11. That's the domain. What about the range? Well, you could put down negative infinity to positive infinity, or you could put down all real values. Okay, all the numbers are included. Is it a function? No. And that's because there's many outputs or more than one output for the input. Right? Input's 11. Good. Or you could say fails the vertical line test, because it is a vertical line. All right, here we go. Almost done, folks. Here we have the Ferris wheel graph. So looking at the Ferris wheel, tell me the domain. So the domain is from here to here. What is it? X is between what? 0 and 80. And it also includes 0 and 80 because it touches. Now tell me the range. Tell me the range values. Y is between what? 2 meters and 18 meters. So I have two questions for you. How long is the Ferris wheel ride? 80 seconds, right? From 0 to 80, that's how long the ride is. How high is the ride off the ground when you get on? 2 meters when you get on, right? So at the bottom, you have to go onto the platform, you're 2 meters high. And at the top of the ride, how high are you? 18. Okay. How many times do you go around? Good. Is it worth the $5?
No.
Okay, that's a different question. Okay, so what I want you to do now is we're going to have another situation. I want you to graph this. So turn this into y equals mx plus b. Okay, so leave the negative 2y, but move the other terms to the other side by adding or subtracting. So it's just like a recap of the test you did, folks. So you should get a minus x and a minus 2. What's the next step? How do you get rid of this negative 2 times y? Well, it's divide. So we divide this side by negative 2, and the entire other side gets divided. So you're going to get y equals negative 1x divided by negative 2 minus 2 divided by negative 2. I'm showing lots of work because you guys struggled on that last test. Now I simplify my signs. Y equals 1/2 x plus 1. Graph that. Start at the plus 1. That's your intercept, your y-intercept. And then use your slope to count. Go for it. Graph that line. So here's plus 1. And count up 1, right 2. Up 1, right 2. Up 1, right 2. And go the other direction. Make sure you know what I'm doing here, because this is the bread and butter of the next unit. Okay, then you can make a line and graph it. Isn't it pretty? But here's the deal. It's not what you want, because now you're seeing the domain has specific values. You're between 4 and -4. So here's x is -4 is right here, and here's x +4. What those points, you have to decide whether you should use an open circle or a closed circle, and then the line can only be between those points. So you're going to have to erase the line a little bit, because it's not a full line, it's just a section. So looking at the -4, do we include the -4? Is there an equal to part? Absolutely. So I'm going to make this nice and big. Okay. But what about the +4? Is it included? No. So right here on the line, I'll make it an open circle. Now I have to erase everything outside of those points. So here, my line goes from the bottom point, which is an open circle, sorry, closed circle. There you go. So that's what your line should look like. Open circle at the top because it's not an equal to sign. Your domain is just a small section of line. So when you're doing questions like this, draw the big line and then figure out what your range or domain should be. Open circle, closed circle, and then erase the rest outside those points. Any questions? Okay, we covered a lot of